Before I go any further, I want to tell you what this circuit does. And this circuit H, 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 H. The tensor product of n Hadamard matrices applied to X, where X is something in the 0, 1 basis of these qubits. So X is a bit string of length n. Is equal to well, suppose this is 0, 1, 0, 1, 1. Here you get 0 plus 1, 0 minus 1, 0 minus 1. And I should really put a 1 over 2 to the n over 2 in front of all of these. So 0 plus 1 is, so what we get is this product. And let's normalize it. So suppose we got this answer. Let's call it y. What would be the coefficient on y? Is equal to, well, it's a sum of a bunch of these things. But let's look at one of them in particular. What would the coefficient on y be? Well, you would get 0 for the first bit. You would get minus 1 for the second bit. Let's make this a 1. You would get a 1 for the third bit, and 0 minus 1 is the last one. You would get a minus 1 for the fourth bit. So this would be a plus. And in fact, if you expand this out, you get a minus 1 exactly when X has a bit that is a 1 and Y has a bit that is 1. So let's put a 2 to the n over 2 here. So what I want to claim is that this is equal to 1 over 2 to the n over 2 sum minus 1 to the sum xi yi I equals 1 to n y, where xi is the ith bit of I, and xi is the ith bit of x, and yi is the ith bit of y. And what is this thing? It's the inner product. It's x dot y. So this is equal to 1 over 2 to the n over 2 summation over all y in bit strings of length n minus 1 to the x dot y y.